Yes, I once again welcome you all of you the lecture series of microprocessors and microcontrollers. So, today is day 15 and date is 10/5/2021. So almost all we are completing the 15 classes. So we are in second chapter. Now we are going to discuss today maximum mode operation of 8086 microprocessor and control signal interfacing and read and write cycle diagrams of 8086 microprocessor and maximum mode operation. Okay, so you know that so there is this operations maximum mode timing diagrams and these are very much similar to the 8086 microprocessor general bus operation. Okay, what is that general bus operation? General bus operation means it can perform the read operation as well as the write operation. When will be the microprocessor perform read operation? Whenever the CPU is want the some data from the memory, and the time microprocessor perform the read operation. Whenever CPU want to send the information or the data that is present in the CPU to the memory, and that time microprocessors perform the write operation. Okay, microprocessor performs simply two operations, write operation as well as the read operation. For that purpose, microprocessor is generating the different number of clocks. For read operation, it generates the 4 clocks. At the same time, for write operation, it generates the 4 clocks to perform the operation. Okay, before going to that one, once again we will see the last class what we are discussed here. In the last class, we are already discussed the general bus of nothing but the minimum mode operation of the 8086 microprocessor. Okay, you see this once again what we are discussing in the last class. Yes, see this. You know that CPU as well as ALU. Okay, CPU, ALU, and all you know that very well. Okay, here we are going to interface this memory as well as input output device. We require different types of devices, latches. Okay, then trans receivers, then input output devices, then a clock. Okay, some interfacing units. What are the interfacing units? You have 8255 PPI, then 8279 keyboard or display interface, etc. Or USART. Different types of devices are needed to interface the memory and input output device to this CPU. So our intention is here how the CPU is work in minimum mode, then it is connected to the memory. So on that purpose, it requires the latches, trans receivers, and input output devices, and some clocks and all. So what are the latches? Latches are nothing but the some flip flops, you know that. So this is the timing diagrams of the minimum mode nothing but the general bus operation. So it is quite similar to the timing diagrams of the minimum mode operation of 8086 microprocessor. You know that so this is the read cycle, this is the write cycle operation. So for the general bus operation, you just simply combine these two only. You cannot confuse that one. So microprocessor performs separately read operation, and then after the write operation. Microprocessor is not combinedly perform the read and write operation at a time. Microprocessor perform the operations step by step only. Remember, step by step. This is the one instruction. This is the another instruction. So microprocessor perform read operation, then only write, or otherwise microprocessor perform write operation and then the read operation, and not the microprocessor perform two operations at a time. For our simplicity purpose, so they are explaining purpose. This general bus of they are combining this read and write cycles only. Remember, okay, minimum mode operation. So minimum mode operations. So for the by while you are connecting any CPU or this microprocessor to the memory. So we require the different types of latches, okay, transceivers, clock generator, input output devices, and all. So how we will convert some one mode to the another mode? You have the some pin mn/mx bar. You know that pin. If it is equal to one minimum mode, you know that it is equal to one minimum mode. It is equal to 0 maximum mode. Okay. If it is equal to 1 minimum mode, if it is equal to 0 the maximum mode. You know that why? Why? Because this is the negative logic. So this is the positive logic. So when this pin is going to the 1, microprocessor is connected to the minimum mode. Okay, so that's why we are putting the logic to the 1, nothing but the minimum mode. Okay. So what is latch? Latches is nothing but a D-type flip-flops. Okay, why you are using this latches? So you know that we have the address AD0 to the AD15. Okay, then what are the other numbers? A16 to the S3, A19 to the S7. We are going to convert address to the data buses or address to the status. We are performing the ALE, address latch enable, latch, address latch enable, address latch enable. This is the meaning of address latch enable. So for this latching, nothing but one state to another state by converting this address to the data or converting this address to the status. So the requirement for this one is mainly conversion one form to the another form, because a microprocessor is a 40 pin microprocessor only. So can use these pins for more effective way. You can use same pins for different purposes, that we can call it as a multiplex lines. Okay, so to convert one form to the another form or one state to the another form, we are enabling the address latch enable. Okay, so for that purpose we require the latches. That latches are nothing but the D-type flip-flops. That numbers are 74 ls 373, and so we have the address 20-bit address. You know that we have the 20-bit address, 20-bit address, and 16-bit data. So for this one, we require the 3 into 8-bit latches. So for this one, it requires 2 into 8-bit latches. So nothing but 16 bits are there, but these are the 24 bits, because so 20 bits latches are not available, because these type of flip-flops available for 4-bit or 8-bit or 16-bit, multiple of 2 power, 2 power 0, 2 power 1, 2 power 2, and so on. These latches are available in the format, but flip-flops format. So these are the latches diagram. This is the address. So series, you have it requires the 3 latches of 8 bits. 3 latches of each of 8 bit, each of 8 bit. Series 8 numbers, 8 numbers. Series 8 bit, series 8 numbers. So this is the data bus. For this purpose, it requires only 2 latches, each of 8 bit, each of 8 bit. Okay, so this is the control diagram, control structure. So these are the pin numbers, pins, RD bar pin, IO by M bar pin, WR bar. What is the RD means? Read operation. Whenever microprocessor is perform the read operation, it can be enabled, nothing but it will be 0. Then write operation. Whenever microprocessor is perform write operation, it will be 0, because it is negative logic. 0 is on, 1 is off. Then this is the one pin. We have the memory and as well as input output device. So we want to see this microprocessor, whether the microprocessor is connected to the memory or input output device. So for this our discussion, microprocessor is able to connect or nothing but the CPU is able to connect the memory only. So that's why M by IO bar is equal to the 1. So it is the memory 1. If it is 0, nothing but IO bar is 0. It is nothing but the input and output devices. Input and output devices. Okay. So this one, this is the decoder circuit, 3 to 8 decoder. The inbuilt decoder circuit is there, like this. We have some gates and AND gates and NOR gates, like this gates. So these are the outputs. This means memory write. M means memory. Remember, IO means input output devices. Memory write operation, memory read operation, input output write operation, input output read operation. All these are negative logics. Remember, these are negative logics. But 0 is on, so 1 is off. Similar. Okay. So transceivers. Why we require transceivers? Transceiver. The name itself gives some answers. Transceivers, data purpose. So our data, what are the data buses? Is 0 to D15 is our data bus. So whenever you want to know that, or whenever you are sending the which type of information, whether the sending information or receiving information are correct or not, and all these things are going to see by this transceiver. So one of the pin we are using for this one is data enable. This will tell us that whether you send the correct information or not. So these two pins, whether you are sending the information or receiving the information, data sending and data receiving. Why? Because the data bus is a bi-directional. So you can send the information, you can send the information at the same time you can receive the information. That's why you can data transmission, data receive. Okay. Then clocks, you know that 806 microprocessor, three different clocks, 3 megahertz, 8 megahertz clock, then 10 megahertz clocks are available. So this is the diagram we are going to discuss in the minimum mode operation. This is the DMAX. So nothing but we have, you know that what is the input of this DMAX is nothing but 3A is to 8 mux. You know that we are already seen that mux. So this is the mux, or nothing but the decoder we are going to discuss. So this is the mux. This is the latch. You know that latch. This is the address latch. This is address latch. Address latch. How many latches are there? 3 latches. This is the address latch, 3 latches, and data purpose you require 2 latches. Totally 5 latches are there. This is the trans receivers. So this is the DMAX. So now this is another one, control logic. You know that memory is divided into the 2 parts, RAM and ROM. RAM and ROM. So this will control logic will going to decide whether our CPU is connected to the RAM or ROM. So that's we can call it as a chip selection logic. CS means chip selection logic. Chip selection logic. Chip CS means here chip selection. These are chips. RAM is on chip and ROM is on chip. Whether this CS will decide that whether that microverse is connected RAM and ROM. So what is CSE? CSO means here C again. CSE bar means here CSCO bar means again this RAM is connected to the even memory, even and odd address. This RAM is divided into even and odd. At the same time, ROM is connected to the even and odd addresses. Physical memory is divided into the even and odd addresses. So that's why CSC means here even, CSCO means here odd. Okay, so this simply this is CPU, CPU is connected to the memory. So for this purpose, so we require DMAX series. We require DMAX. So and latches, then trans receivers, then control logic. So the 4 hardware devices are required to connect the memory. At the same time, we are also required some interfacing devices also. So these are the memory. This is the RAM and ROM are the memory. These are the input output devices. So but microprocessor is only connected the input and output whenever IO by M bar is equal to the 1 or M by IO bar is equal to the 1, then only microprocessor is connected to the RAM and ROM, otherwise it is connected to the input output device. Okay, so now this is some go to the timing diagram. You know the timing diagram. So what is a pictorial representation of the operation performed with the microprocessor? You can simply can go for the, you can call it as the timing diagram. So in the timing diagram we are going to discuss, we have 3 different states. So first is the state. One cycle of a clock is called a state. One cycle of a clock is called a state, or one time period, T1 time period. state. So what is a mission cycle? So microprocessor is performing one operation such as read operation or write operation. So it requires one mission cycle for read operation, for suppose. So T1, T2, T3, T4, TW, T4. This is one mission cycle. But for some operations like send in some stack and some other instructions, some operations, microprocessor is required more number of mission cycles to perform that instruction cycle. An instruction cycle is nothing but a time required to. Time means here the number of cycles required to microprocessor to complete a one instruction is called the instruction cycle. So for that, whenever you want to whenever microprocessor want to perform the one instruction cycle, it will require more than one mission cycle. Remember, more than one mission cycle. Now see this. This is the minimum mode operation of the timing read diagram. Read operation, a read cycle is a read cycle. You know that read cycle. You know that in this T1 clock period. So T1 clock period. So this is, you can call it as timing diagram. But microprocessor is performing the read operation is like this. So this is the address. So whenever you want to on the ALE and enable the ALE on this T1 clock period onwards. So a T2 time period is required to convert address to the data. So after T2 clock cycle, so now see this an address bus. You know that address lines are two different categories. What are the two different categories? AD0 to the AD15 one category of address lines. What are the another one? A16 to the S3 or A19 to the S7. Two different categories of address lines are there. So totally you have the 20-bit address. Okay. So then D0 to the D15 is the 16-bit data. Remember, 20-bit address and 16-bit data. So this address lines you are converting to the data once you can on the ALE. So at the same time, this address lines is also converted to the status. Now see this. This address lines is converted to the status lines. Now see this. A19 to the A16 lines is converted to the. So when it will be converted into the T3 clock period onwards. Why? A T2 time period is required to convert some address to the data or address to the status lines. Status. Again, now see this one category is completed. What is the another category? AD0 to the AD15. Now see this under T1 clock period, it has the address lines. Once you are enabling T2 time period or once T2 time period is comes, so this address lines is converted into the data lines. Now see this data lines. See this data lines. But when this data lines is performing, so now see this. Whenever you are performing the read operation, RD bar means here 0, nothing but 0. So on that time, whatever the data that is available on that address, for suppose CPU, this is memory. These are the address lines. These are the address lines. For suppose our data is there. Our data is there. This is the address. 1000001 is the address. This is the bus address. This is the bus. So whenever CPU and the T1 clock period, microprocessors identify this address. Remember, a T1 clock period, microprocessors identify this address location on the memory. Remember, once T2 clock period is wasted to convert this address lines to the data. Remember, by seeing this diagram, you should remember at T1 clock period, remember microprocessor connected the whatever the data you want on the memory location. At T1 clock period, microprocessor is identify the address location of the data. Then T2 clock period is required to T2 clock period is required to convert some address to the data as well as address to the status. Then once data is identified the microprocessor, then how to get the data from memory to the CPU? It perform the read operation. So So microprocessor perform the read operation. When it will be performed read operation? At T3 clock period onwards. See this. At T3 clock period onwards only it will perform the read operation. Otherwise, why it is not performed T1, T2? Because under T1 and T2 clock periods, okay, at T2 clock period it is in address mode, and T2 clock period and it is in conversion mode. So that's why whenever you want to perform the read operation, so microprocessors enable the read operation at T3 clock period onwards only, because on the time period only this data bus, this address bus is completely converted to the data bus. Once the read operation is performed, so for that perform the read operation requires the 4 clock periods, nothing but 3 clock periods. So T3, TW and T4. You know that what is the TW? And TW you can also call it as a wait time or inactive time. Why it is generated by the microprocessor? Microprocessor is not always generated by the microprocessor. This is generated whenever the connected memory is slow device. Okay, whenever this connected memory device is slow when compared to the CPU, on the time microprocessor is generated this TW to match the speed of the CPU as well as the data. So read operation, so performed by the T3, TW and T4 time periods. Once read operation performs, then data is there. So for suppose the data is, so 1101 is our data. So once the read operation performed, so the data is available at the 1101, but microprocessor is not transferring the data. It's check whether that data is correct or not. Once it is checked, so for that purpose again it is 0. Nothing but 0 means DN bar on. So it is on. So data enable. So once it is checked whether the data is whether that available data in that bus is, remember. So microprocessor is not taken the data. So it is available at the bus. So this lines available in this lines only. So it is not coming back to the CPU. Available in these lines. So once it is available, so microprocessor is generate data enable. So because it checked whether that available data is correct or not. Once it is correct, microprocessor perform the data transmission and receive. So we perform the receive operation. So perform the receive operation. Then whatever the data 1001 it is available in this data is coming to the CPU. 1101 CPU. So see this once again. So at T1 clock period is required to in this T1 clock period the buses are in address mode. At T2 clock period, whenever you want to enable the ALE, the address lines are converted to data as well as status lines. Once that it will require the T1 T2 clock period. So then T3 onwards you on the RT. So read operation. Once the read operation is performed, whatever the data that is available in that memory, that is available in the data bus only. Remember this bus only, but it is not transferred to the CPU, because whether the CPU check whether the data is correct or not. So that purpose is required the GEN bar. Once the data is correct, microprocessors perform the data transmission receive operation. For that read operation perform the receive operation, then only that available data in that bus is the data bus is back to the CPU. So this is the operation. At the same time maximum minimum mode operation of the minimum mode operation of write cycle is also very much similar to this one. So at T2 T1 clock period, this is the address. What is the write operation? The CPU to the memory. CPU to the memory. CPU to the memory information. Send the information from CPU to the memory. So ALE again on the ALE. So in this one we have the data and the address buses. At T2 clock period is required to convert some address to the data as well as status. So after that, so this is the data bus. Data bus. This is the status bus. These lines are converted into the. These lines are address or data is converted to the after this 3 to 3. Yes, remember only this you should draw in the examinations only up to the T4. You should avoid this T1 clock period. Okay. Okay. So so once this operation T3, TW and T4, These lines are available at the status lines. These are status lines. These are the data lines. So hence microprocessors perform the write operation here. Write operation. Whatever the data present in this, for suppose this is the data. This is available at the bus only. Remember, this is CPU. This is memory. Available at the bus. This is the bus data. Bus only. Once it is performed, data enable operation. But whether you send the information is correct or not. Once it is correct, then microprocessors perform the data. See this data transmission receive. But it is 1, it is 0, and it is 0. So data transmission. So the data is transferred to the specified location. This way. So T1 clock period is identify this address location. Okay, so this is the way you are connected, you are performing the right operation. Now this is the one type of timing operation, nothing but whether the microprocessors know that whether the operation is completed or not. So for suppose microprocessors perform the read operation, so for that purpose microprocessors generate 4 clock cycles, clock cycle clock cycles, or one machine cycle. So microprocessors know that. So whether it is completed read operation or write operation. For that purpose, it generates the hold signal. Whether that microprocessor is completed that operation, it gives acknowledgement, hold acknowledgement. So this hold acknowledgements you can also use it in the DMA, direct memory access also. Okay, this is the way we are connected the you want to see the some minimum mode operation. Now going to see the our topic, today's topic, maximum mode operation. Okay, maximum mode operation of 8086 microprocessor. Maximum mode operation. Okay, see this microprocessor. The CPU is working minimum mode as well as the maximum mode. So for that we have the pin mn/mx bar is equal to 0 is nothing but the maximum mode. Whether it is 1, it is nothing but the minimum mode. So you put that pin to the 0 for operating the maximum mode. So you know that 32 pins are common for both the minimum and maximum mode. Only 8 pins are different for minimum to maximum. Okay. Now see this general bus operation. You are already seeing this. So now see this. For performing this operation, mn mx bar is put to the ground or nothing but the 0. So this maximum mode operation you can also call it as a multi-processor mode. Minimum mode operation you can call it as a single processor mode. But this maximum mode you can also call it as a multi-processor mode. Remember, maximum mode you can also call it as a multi-processor mode. So nothing but for this maximum mode operation also, microprocessors perform the read and write operations. Read and write operations. Okay. So you can see this how this minimum mode operation is work. So whether you are connecting this maximum mode to that the maximum mode nothing but 8086 to the memory, you require again latches, transducers, and all. Okay, and again you can see this again that all are same. All the things for minimum mode, maximum mode are same. Only difference is pins. Pins we are using pins. Only difference is pins. The diagrams is almost all equal. Almost all same diagrams. You know that these are the latches. These are the trans receivers. These are the bus controllers. It's nothing but the DMAX. You know that read write to IO read IO write operations. Again, chip selection. Okay, so this diagram is very much similar to that. One. The only difference is for the mux operation, DMAX operation. Here in the previous diagram, 3:8 DMAX, we are using M by IO bar pin again. RD bar pin. Again, we are using WR pin. So then now it convert into the memory read operation, memory write operation, okay, IO read operation, then IO write operation. But for this maximum mode, we are giving the signals like the maximum mode. We are giving the signals like, okay, S0 bar, S1 bar, S2 bar, as well as clock. You know that clock for this one. See this for this one. The only difference is like this. The only difference is S0 bar, S1 bar, S2 bar. So in this is the so this is the minimum mode. This is the maximum. So nothing but see this again. DMAX S0 bar, S1 bar. We are using S3 bar. You know that clock and all. So then output is same. Memory read, memory write. Okay. Then IO read, IO write are same. The inputs are same. Nothing but the pins are different. You know that the pins are different. So in the minimum mode, we are using the pins called M by IO bar, RD bar, and WR. But here the pins available in maximum mode is S0, S1, and S3. So remaining all are same. Remaining all are same. The way you represented here is only the difference. Here in the minimum mode, you represented the M by IO bar, RD bar, and WR bar. But here in this, we are representing the S0, S1, and S2 for this one. Remaining all are same. Control logic and latches and data buffers, whatever we are using, both are same. You know that the only difference between this maximum mode to the minimum mode, only the 8 pins. The pins are changing to the minimum mode to the maximum mode. The change in pins here S0, S1, and S2. Okay, now see this operation is very much similar to the minimum mode as well as the maximum mode. The pin names are changed here. See this, only the pin names are changed, only the pin names are changed here. You cannot confuse that. So again, T1 clock period is required. A T1 clock period, again here again you see this, a T1 clock period is required to address. So this is the read cycle. Nothing but a CPU is connected to the memory. CPU is whatever the data that is available on that memory, that is coming back to the CPU. So another memory to the CPU. Memory to the CPU. So for the T1 clock period, microprocessors identify the address location. For suppose this address location 1001. So on that one we have the data. Again, a T2 clock period is required to the this address lines to the status lines. They again same minimum mode. There is no difference between minimum mode, maximum mode, read and write cycles. Only the difference is change of the pins. Change of the pins we are going. So again, the address lines are connected to the data. For that purpose, a T2 clock period is required. So now this T3, T4. Now see this, you can avoid this one T1. You can draw the examinations only up to this one. So in this T3 and T4 clock periods are TWR. Whenever you are interested, you have to perform the TW also, not an issue. So T3 and T4 period. So that whatever that address bus is converted to the status bus address bus is converted to the data buses. Then here on that microprocessor is perform the read operation. Yes, you know that. But here the pin is memory read, MRDC, nothing but memory read. So it is also but nothing but 0. Once it is performed this operation, whatever the information that is available in that data. So for suppose the data is 08H, that is coming back to this bus, but it is not going to the CPU. Once it is you can perform the data enable. See this data enable is there is no bar in this one. You can perform this one. So now why data enable? You can check the data is correct or not. Once the data is correct, microprocessors perform the D2 by R bar. So receive operation. Then only the 0 ahead edge information is coming to the CPU. The only difference here we are going to here, instead of RD bar, you are using MRDC bar. All other states are, all other diagram is very much similar. So nothing but you know that S7, S3 pins as well as AL. So the here additional we are drawing this one. Okay, remaining all are same. Okay, remaining all are same. Again, this is the maximum mode operation. So this is the maximum mode operation. So this is also very much similar to the minimum mode operation of a write cycle. So this is maximum mode operation of write cycle. Write means here, CPU to the information memory. CPU to the memory. Whatever the information that is stored in the CPU, that is send it to the memory. So write operation can from the write operation. So for the T1 clock period, microprocessors identify the address. For suppose 001 again that address. So in this address we have the address. Microprocessors perform just address. Okay, microprocessors perform the address. You know that. So for this address, there is a some data also. There is a some data also because you know that microprocessors cannot erase the data. It can only overwrite data. So it is already a previous data is available. So whatever the data you send it to the memory on that address, it is just overwritten. Remember, okay? So T2 clock period is required to convert that address to the data, So now see this. So these are converted to the data. Okay. Then after microprocessor is performing the write operation. See this the pin. So this is not because you are performing on the memory read. So for the memory read operations. So you will erase these pins. So the IO means here write operation, but you are not performing the input output write operations. We are performing on the memory read. You can for that purpose we are using the pins. Okay, we are using the pins this one. So we are also cancel this one. So there is no use of this one. We are also cancel this one. We are also cancel this one. We are also in the examination we are also erase this one. See this. So please note down this one. Erase this. So there is no use of this one. So once it is data, write operation in the minimum mode you have it is write operation, maximum it is MWC bar. Okay, once it is performed, the data for suppose again 078 is our data. So that is available in this bus 07. That is available in this bus 07. See this 07. 07 is available in the bus. Now this checks, microprocessor checks DN bar. It checks whether the data is correct or not. Whether the data is correct or not for this enabling the DL. Once it is correct, it can perform the D2 by R bar means here 1. So you can draw this way. Remember this way. So a mistaken they can given in the textbook. So draw this way. This way. This way. You can draw the, so you can follow the red line. So you can this way. You can delete this way. You can erase this one. You can erase this one. Okay, this way. So data enable is also easier. Just 1 sec. No, data enable is also this. Okay, whatever. No, see this data enable means. So you can delete this one and then you can modify this this one. Okay, modify this diagram to this one. So for that purpose, it requires the T3 and T4 clocks. Okay, so at the same time, whether the microprocessor knows that whether this read operation and write operation is completed in maximum mode operations. For that purpose, microprocessor generates the request. So that request is accepted, that one, then it can that is generated by the grant. So this is the request and grants. Okay, this is the operation of the max mode operation of the 8086 microprocessor timing diagrams. Very much simple. So see this entire diagram is common, it was same. The only difference we are going to see is here in a minimum mode we are going to use the IO by M bar, RD bar, WR bar. Here IO by M bar or M by IO bar, whatever. Remaining all the things are same. Here you can also change the inputs. Okay, so this is the DMAX diagram. So this is the DMAX. Okay, so remaining this latches. So for the data purpose we are using 3 latches. For address purpose we are using for the address purpose we are using 3 latches. For data purpose we are using 2 latches, 5 latches we are there. So this is the trans receivers, nothing but for to enable the data at the same time DT by R bar. So chip selection logic is used to select the RAM and ROM memories. Okay, RAM and ROM memories. Okay, so this is the timing diagram. You know the timing diagram very much. So read operation means here whatever the data present in the CPU, nothing but memory that is we are stored into coming back to the CPU. You know that T1 clock period. So the all are in address mode. Whenever you want to convert that address to the data, so T2 clock periods are required. Nothing but you want to enable this address latch enable. So at T2 onwards, these the address lines are converted into the data. See this data lines. See this data lines. These address lines are converted into the. This is the data bus, and these are the status bus. These are the status bus. Once microprocessor perform the read operation, is nothing but MRDC in maximum mode. So nothing but see this read operation. Read out whatever the data present in this memory that is available in the data bus. Available in the data bus for suppose 088, but it is not going to the CPU. It is just available in the this bus only. Then microprocessor checks whether that data that this bus data is correct or not. If it is correct, microprocessor perform the data transmission result. Then this bus data is coming to the CPU. Similarly, this is also very much quite simple. So write operation. This is also very much quite equivalent to the minimum mode operation of the 8086 microprocessor in write cycle operation. Now see this at T1, it is in address and data. So you can enable the ALE, then it will. So to enable network conversion, converting address to the data request T2 clock period. Once T2 clock period is over, now see this data bus. This is the data. So at T1 clock period, so microprocessor is identify the address location of that memory. Once that address location is available, it can perform the. So nothing but it can perform the ALU. So nothing but address bus is converted to the data bus. Once data bus is converted into the data bus, then microprocessor perform the write operation. Write operation. Now see this here, a write operation here, a write operation. Write operation. So nothing but whatever the data in that CPU is available at the data bus 07 for suppose, just for example 07. So it is not stored at the memory location. Then microprocessor perform DEN, nothing but data enable. So whether it checks whether that given data is correct or not. Once it is correct, then microprocessor perform the DT by R bar. So data transmission. So it is 1. So there is a mistake here. So you can draw in this way. So this is the write cycle. So this is bus request and grant signals are request and grant. RQ means here request, GT means here grant signals to know that microprocessor is completing that read operation and write operation. Okay, it first send the request signal. So if it is it is responded by the timing and control unit, then it will be sent back to the grant signal. Then microprocessor knows that. So okay, that operation is completed. At the same time, this request and grant signal we are also using in interrupt operations also. Then input output devices operations also. This request and grant operations especially used in the some printing applications and all. Okay. Okay. So So thank you for joining today's class.